Today we need to cover the change of base formula and expanding log expressions. And first, the change of base formula is very easy. And what do I mean by the change of base anyway? Well, what if they ask you to find or evaluate something like this: log base 4 of 30. Well, this problem would be a challenge if I tried to do the switcheroo, and set this equal to x, and then said 4 to the x equals 30. That's going to be hard, all right, because I can't raise 4 to a power and get 30. But I can do this problem with a calculator using the change of base formula, and it's super simple. All I have to do, and I can use either the common log or the natural log. All I have to do is, let's say that I'm using natural log. I would write this as the natural log of 30 divided by the natural log of 4. And perform that calculation with a calculator, and it will give you the answer. All right? So, and even the basic TI-30 calculators will do this. So if I do the natural log of 30, I'm just using a basic calculator here, I get 3.40. And if I do the natural log of 4, I get 1.39. And so if I do the division, I get 2.45. Okay? So, and you can use this formula with the common log too, and I would get the same thing. I could have also done this with the common log, log base 10. I could have also done the log of 30 over the log of 4 on the calculator, and I would get the same thing. Okay? So that's the change of base formula. We don't need to spend any more time on it. I'll give you some questions tonight in homework where you get to do that. Where I want to spend more of our time is on some log properties. And what a lot of people call expanding log expressions. My pre-calculus teacher in high school did not spend a bunch of time on this, and it really hurt me when I got to calculus. So I've always made a big deal out of making sure that we know log properties. Okay? First one, the product property. The product property of logarithms is easy, and these are all the same whether it's a common log or the natural log. It doesn't matter. So, let's say that I have the log of AB. Now notice that's A times B. Okay? That's why this is called the product property. I have a product of things. The log of AB is equal to the log of A plus the log of B. I can split it into two logs added together. That's the product property, okay, if I have the log of AB. All right? So, for example, if I had the natural log of 5x, because remember I said this is true for the natural logs as well, that's the same thing as the natural log of 5 plus the natural log of x. And this comes in very handy in a lot of situations. Now, that's the product property. The quotient property, we can just use some common sense. For the quotient property, if I have the log of A divided by B, since dividing is the opposite of multiplying, it makes sense that instead of adding them together, I will subtract. This will be equal to the log of A minus the log of B. I need to put in my G in there. Log of A minus the log of B. All right? So, for example, if I had the log of x over 7, I could write that as the log of x minus the log of 7. Okay? Another property. It's very handy, called the power property. The power property for logarithms, and again it's true for common logs and natural logs, says that if I have the log of a to the n power, this power property says that I can rewrite this with the n out in front as n times the log of a. Nice little property. Again, it helps simplify things for me a little bit. So for example, if I had the natural log of x to the 7th, I could write that as 7 times the natural log of x. Nice little property. All right. So, what are you going to be asked to do with this tonight? They're going to ask you to expand an expression kind of like I've been doing. All right. Before I do that, though, there's a couple of let's call this other properties. And the reason I'm calling these other properties is some of these we've already talked about. Okay, some of these I've already pointed out to you. Here's the first one. This one is huge. The natural log of e to the x is equal to x. Or in other words, the natural log of e to the mess is equal to the mess. No matter what this is up here, it can be simplified to just this. If I have the natural log of e to a mess, it's just equal to the mess. And it works the same way with a log if the base is a, and then it's the log of a to a power, it's still going to be x. All right, so in other words, if these two things are the same number, all right, it can just simplify to the exponent. It's automatic property. All right. Here's another one. What's the natural log of e? 1. Okay, the natural log of e is 1. Same thing if I have log of base a of a with no exponent, it's just equal to 1. Okay, so those are some very helpful properties. Here's one more. How about log base a of x equal to log base a of y? Now this one's a little bit of common sense, but all we need to know is if I'm taking the log of an expression on both sides, so long as the bases are the same, I can drop the logs, and I just know that x equals y. All right, so you might want to say if, then, something like that. All right, so tonight they're going to ask you to use some of these properties to expand. Some of this will be very easy. Other parts of it will have a little bit more of a challenge to it. So I'll start easy. What if they have the log of 8x? We'll start with an easy one. If they give you the log of 8x and ask you to expand it, you just use the product property that says this is the log of 8 plus the log of x. Do you see why it's called expanding? Isn't it stretching the expression out? That's why it's called expanding. Okay, that was very easy. Let's do one that we have to think a little bit more about. How about the natural log of the cube root of r? Well, we don't know anything about that radical symbol, but I do know something if I write this as the natural log of r to the 1/3 power. And if you remember the power property I just showed you a minute ago, this 1/3 can come out in front. So this is 1/3 times the natural log of r. And that's how you would treat that problem. Okay. Try to keep getting more difficult here, because I know that's where a lot of your questions would be. This is a good one. The natural log of x squared minus 4 over x to the 5th. Now this one is putting several properties together. It's actually putting the power property, the product property, and the quotient property all together. All right? You see I've got a quotient here. All right? This thing is a quotient. So what I would do first is split it up with the quotient property. Make this the natural log of x squared minus 4 minus the natural log of x to the 5th. Now sometimes people ask, how do I know when I'm done? Well, when you've done all you can do. There's more that I can do with this. Because can't I write x squared minus 4 as a product? Can't I write this as x plus 2 times x minus 2? Right? So now I've got the natural log of x plus 2 times x minus 2 minus the natural log of x to the 5th. So on that first log expression, I can use the product property. Right here I can split this up and make it the natural log of x plus 2 plus the natural log of x minus 2 minus, is there something else I can do with the last one? I can bring the 5 around. 5 times the natural log of x. Now we're done. All right. Let me just do one more. How about the natural log of the cube root of x cubed over y squared? Now this one is an interesting situation because I've got a root of something that's to a power and it's also a quotient. So here's the way I would tackle it. I would take care of this root first. I would make this the natural log of x cubed over y squared all to the 1/3 power. And there's a couple of different ways you can go from here. You could distribute this power to both, or you could just bring it out front. Either way will lead you to the correct answer. All right? So why don't I just distribute it to both and see how this turns out. That's going to become 3 times 1/3 is going to become 1, the natural log of x to the 1. That's nice. On the bottom, 2 times 1/3 is going to be 2/3. Now I've got a quotient. Now I can split it up using the quotient rule, quotient property. The natural log of x minus the natural log of y to the 2/3. And then bring your 2/3 around. So this would be the natural log of x minus 2/3 the natural log of y. Now notice I said that's one way you could have done it. If I would have brought the 1/3 out in front first, I would have had 1/3 times the natural log of x cubed over y squared, and then when I broke it up, I would have to multiply 1/3 by both of these, like that. The reason I'm showing you that is because there might be a case where that way is better. All right, I can still get to the correct answer. Okay, bring your powers around front. and I have 1/3 times the quantity 3 natural log of x minus 2 natural log of y. And then if I distribute my 1/3 to both of these, 1/3 times 3 is 1, and I have the natural log of x minus 1/3 times 2 is 2/3 the natural log of y. That way was not as easy in this case, but there might be another problem where that way is easier. That's why I'm showing you both ways on this problem. And we're going to stop there for today.